Hey everyone, it's the Vigilant Christian Mario. I'm actually really excited to make this video to let you know about a new outreach ministry that I'm going to be starting, and I'm going to show you how I'm going to do it here on this YouTube channel. I believe I'm the first one to attempt it, and what it is to leverage the technology of virtual reality that's going to get really popular in order to spread the gospel. And so now, as the technology evolves and the virtual reality becomes more popular, what I plan to do is to use that to get to the youth.
No, just no. I can't take this anymore. I need a break from religion. Oh, come on, please.
No.
Come on. There has to be something I can debunk besides religion. Hello?
Hey, I found you a video to debunk that isn't about religion.
Do you have my house bugged?
I sent you the link.
Dick.
Yo, coming at you again. Star Gods back in the saddle. I want to talk about certain aspects that NASA stands behind, but I don't get it. I'm a simple man. I observe and I have a sense of logic, my own logic, but I'm not an expert. And I didn't go to years I didn't spend years in school, and I'm not a master physicist and blah, 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 blah. I'm just a simple man that doesn't understand. There's things about NASA pushes down my throat that I don't understand.
That's completely understandable. Science can be complicated, and there's no fault in asking questions.
Okay, I made just a short list. I have a huge list. This is just a short list. Okay, so you have the Earth, and it's a round ball. It's a round bale. And so it's covered with water. It's covered with tons and tons and billions and trillions of tons of heavy water. Just get a big, huge container of water and see how hard it is to lift it up. But what makes it stick to the Earth like Velcro?
The one-word answer is gravity.
What do scientists say? Well, they got their magician's hat in there. Where's that rabbit? Oh yeah, there we go. Oh yeah, gravity. Tick 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 tick. Yeah, gravity. Right. That makes about as much sense as I don't know. It's just absolute silliness. Gravity. So we have billions and billions of tons of pure electromagnetic dynamic force.
Gravity is not electromagnetic. Those are two separate things.
Pulling the oceans down. The tons and tons and tons and pushing them down. Also holding the mountains down so the mountains don't fly off. Holding the mountains down in these big, huge boulders of billions of tons all over the world, and the mountains and the ocean is just pulling it down, because there's so much power. The power. Oh, let us pray. Dear power of gravity, come unto me. But yet a butterfly can just go bitty, 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 bitty. I could throw a ball up in the air. But, in real life, I should be on the floor going, I can't move. Gravity's got me. Gravity's got me, Ma. Gravity's got me, Ma. Billy's going down. Billy's going down. Does that make sense to you? But yet I could take a coin and bloop, up in the air. I can let a balloon go. A little tiny butterfly can fly around. But the billions of tons of power pressing, compelling the oceans to stay put. And the mountains, we're going around 1,000 miles an hour, but the mountains are happy. because the power, the dynamics, the incredible pressure, the squeezing pressure of gravity. And I don't even feel gravity. So I don't get it. Okay. I do not get it. I don't understand it. But then you look it up in science and I go, oh, well, surely science has the answer. You know, so NASA is the spokesman for science now. They speak for all the scientists.
NASA is not the spokesman for all scientists, but it is an organization filled with scientists that are qualified to talk about all sorts of things.
Anyways, you look it up and you find, oh, gravity. Oh, what's this? Gravity is a weak force. What? A weak force? Well, it's going to pull those oceans down. What's going on? I don't get it. A weak force? Well, Mr. Scientist and NASA, you can't have your cake and eat it too. What is it? Is it a strong power of God pulling the oceans down, keeping the mountains in place on a planet revolving 1,000 miles an hour? Or is there something else that you're not telling us? How can a butterfly that butterfly should just, like that from gravity, it should just pull that sucker down, you know? But wow, it just, and so they say, well, it's mass. That's mass, because you're heavier than a butterfly. You can't, you know. But I can still jump up, even though there's a force of unlimited magnitude of power bringing this down. Even though I'm not as big as a mountain, how can the mountains be held down? It doesn't make sense. You see, it's just common sense. I think the buoyancy, the buoyancy theory is pretty good. But anyways, they say gravity's weak. So there, you just shot yourself in the foot, NASA. Gravity is a weak force.
Gravity is very weak, but the Earth has a mass of around 6 septillion kilograms. That's a 6 with 24 zeros after it. On the scale that we normally experience, gravity is very weak, especially compared to the other fundamental forces. But on the scale of the Earth, gravity is very powerful. The reason that the Earth can hold on to a mountain, but not squash us, is that a human weighs around 100 kilograms, but the average mountain weighs around 300 trillion kilograms. That's a 3 with 14 zeros after it. A good way to think about it is that the gravity works on each atom of an object. For a human, there are 100 kilograms worth of atoms, and each one is held by gravity. For a mountain, there are 300 trillion kilograms worth of atoms, and each one of them is held by gravity. Water is the same way, except for the mass of all the water on the Earth is around 1 sextillion kilograms, or 1 with 21 zeros after it.
Now you have the moon, 250,000 miles away, they say. It's 250,000 miles away. The moon. Well, let me tell you about the moon. I mean, you can get a pair of cheap binoculars and you can zoom right in on the moon's surface. You can see the craters. You can see all the little critters going to McDonald's on the moon.
I'm sorry, what? There are no critters on the moon, and there are definitely not McDonald's franchises on the moon.
And how can you do that? If the moon is 250,000 miles away, how can you take just simple low-grade magnification and you can see craters on the moon? There's only one logical explanation, that the moon is close, very, very close to the Earth.
No. For one thing, the moon is very big, and the craters are also very big. Most craters are around 15 kilometers across, but the largest can be upwards of 500. The moon is very far away, but it is also very big. I've debunked a very similar claim previously, so the link to that will be in an iCard and in the description.
And same with the sun. The sun, we have a hot spot of the sun on the Earth. Let me explain. You have a flashlight, you go up to the wall, really close to the wall. What do you get? Big, round, hot spot of light. Then you pull it back, and it disappears. The sun, you see all these pictures of the sun over the surface of the Earth, and there's a bright, brilliant hot spot below. Why is that? Because the sun is very, very close to the Earth, and it's much smaller. It's not like, a billion times bigger than the Earth. It's very, very small. So how do you explain that? Bright, like it's close. If I go close to the wall with the flashlight, you're going to see it. You're going to see it. Oh, but no, just a sec, gotta adjust my depends. Oh, yeah. No. The sun is big. It's big. It's so big that it makes a hot spot. Where do you get this? Oh. So if I go to the side of a cliff and I have a huge searchlight, it's going to make a big hot spot. Now, if I go back, same thing. Doesn't matter how big it is. Light dissipates. Did you know that? Light doesn't go on forever and ever. It dissipates. No, it doesn't. It goes on forever and ever. That's what the scientists say. You're an idiot. You're a troll. No. Because if I take a flashlight, whoa, it's bright. Wow, look at it. I light up the tree there. How about the trees farther back? Oh, it's getting kind of dim now. How about the trees? It's getting much dimmer. So don't tell me that light goes on for infinite, measures. I mean, it just keeps going on, and light diminishes. So the light from a big sun is still going to diminish. You're not going to get the hot spot. Look at the moon at night. When you see the moon on the water, it's like a search and rescue light. There's a big stream of light going right across the water. A 250,000 miles away. That's a good one, man. Whee!
I'm not completely sure what you're talking about with the hot spot under the sun, but I can explain the flashlight. A flashlight has a mirror that redirects light in a general direction wherever you point it. The light spreads out from the light source, and as the light gets further out, the light spreads out more, so less light hits each point. As you can see from my very simple image, a tree that is closer to the flashlight will be hit by more light, and when it is further away, it'll be hit by less light. There is still the same amount of light, but it's spread over a larger area. A laser is light that doesn't spread out much, which means it can go over greater distances and still have a relatively small spot. The sun, on the other hand, is so big and produces so much light that even at the distance that it is at, there is still enough light to keep the Earth fully lit. If you got closer to the sun, it would light you up even more, just like a flashlight. The moon reflects light from the sun, and some of that light is reflected towards the Earth. The rays of light reflecting off the moon hit the water and reflect off of it. The reason you see a small image of the moon on the water is because some of the light hits the water a bit further away from you, which makes it go over your head. Some of the light hits the water closer to you, which makes it go under your head. And some of the light hits the water at just the right distance that the reflected light hits your head. In this case, you would see the moon's reflection on the water right here.
I mean, 2 scoops, you get an extra scoop. And look how close it is on the water. How can I take little low grade magnification, one of the lowest grade magnification, and look up and practically see little stones on the moon?
You cannot see little stones on the moon. You might be able to see large boulders that look like they're small because of how far away the moon is, but you cannot see pebble-sized objects. As a matter of fact, it is incredibly difficult to see tiny objects that are far away. You need huge telescopes to do it well, which is why people build huge telescopes.
Because the moon is close. I remember one day, I was walking along, minding my own business, and then I saw the sun, and I saw a spot on the sun. And I went, what is that? There's a spot.
So, you were walking along, you looked directly at the sun, and you saw a spot on the sun. Not completely sure, but it's very possible that the spot was a bird, or it could have been because the sun is so bright. Quick experiment, stare into a light bulb for 10 seconds, then try to read something. It's very difficult because there's a hole in your vision where you're looking at the bright light bulb. Don't worry, 10 seconds into an ordinary light bulb probably won't do permanent damage, but I take no responsibility for any damage to your eyes.
Is on the sun, and so I looked it up on the good old internet. There's sunspot activity. There's a medium-sized sunspot on the sun. Well, how could I see it with my naked eye if it's 93 million miles away? Millions and millions of miles away. Millions. I mean, how could I see that? How would it be possible? Come on, NASA, bring it on. Come on, all you know-it-alls. You know it all. Get your magic hats and pull something out real quick. Because I'm not leaving you alone. So how can I see it with the naked eye? No binoculars, nothing. I could see it on the sun, a spot, because the sun is so close. If it was 93 million miles away, that sunspot would not be seen.
The angular size of a sunspot ranges from around 0.02 degrees, the size of a basketball that's 75 meters away, to 0.0006 degrees, which is about the size of a basketball that is 2.5 kilometers away. You're obviously going to have a hard time seeing the smaller ones, but the bigger ones could be seen, assuming you can look at the sun and not have spots in your vision from your retina burning.
And they said it was the size was a small one, but I could still see it 93 million miles away with a small spot. I'm not going to see it, but now everybody's going to go, no, you know, the cow deniers, no, you know, he's going to pop. So the hot spot, how do you explain that? You know, like, but they'll come up with some gibberish, childish explanation for a 2-year-old, you know. Look at the pretty colors, boys and girls, you know. So the hot spot, burning hot spot. Look at these, when they put balloons up, and you can see the sun, and you can see, and it looks close. It looks close.
It's not because it's close, it's because it's so bright and so big that even at 93 million miles away, it is still bright enough to burn our retinas.
Well, it's two-dimensional. Yeah, who cares? It still looks close. And there's a burning, bright hot spot, just burning. That clearly shows nature's flashlight is very close to the Earth. It's not that far away, and it's not that big.
The sun is not a flashlight. It's much more like a light bulb. It emits light in all directions, not in just one general direction like a flashlight.
They say it's 33 miles wide, the sun. Yeah, about 33 miles. 32, 33 miles. That's where you get probably from the Masons, the 32 to 33. And so you can't have it both ways. And the moon, it just looks like a giant search and rescue operation with the big searchlight going over the water. That's because the moon is so close. Figure it out. Now in space you have micrometeors that go dozens of times faster than a rifle bullet. A sniper's bullet is so slow. I think, what is it? 2,500 feet per second? I think I made a note of it here. Anyways, extremely fast velocity. Okay, so micrometeors. Okay, a regular bullet goes 2,500 miles. It's all jumbled up here. Anyways, look it up yourself. Bullets, the average bullet travels 2,500 feet per second. Okay? Micrometeors are small pieces of metal, and they go 22,000 feet per second. That's way, way faster than the Kennedy bullet. I mean, come on, people. That's extreme acceleration. And these things can be as big as your fingernail, like bullet size. And they're very common. NASA says, they're very common in space. I don't know why NASA ever admitted to that. They say the second you go into space, you're bombarded. But fortunately, they're small particles. They're tiny little particles. And they're not like those big bad boys. No, they're little tiny ones. They go peep, 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 peep. And so the astronauts are protected. Well, no. And then at that size, it acts as a sandblaster. You just literally get sandblasted. Any ship that goes up there into space gets sandblasted, absolutely sandblasted. And so now you have these astronauts on the moon, and NASA says the second you go in space, there's the micrometeors. It just takes one going like a dozen times faster than a sniper's bullet. Like that. Oh no, it doesn't go that fast. No. Yeah, it does. Look it up. Anyways, look at the figures of the bullets and all that. And so it doesn't penetrate the spacesuit, because the spacesuit has Kevlar in it. Yeah, Kevlar. Those Kevlars can, I mean, they keep the bullets off, but not high-powered bullets, and certainly not something traveling at thousands of miles per second. You know.
Micrometeorites do go very fast. The difference is that a bullet is pretty big compared to a micrometeorite, which is around 0.1 millimeters across. The momentum of this object is 26.5 kilogram meters per second, which is the same momentum as a car going at 0.04 miles per hour. Now forget everything that I just told you, because the momentum of a 223 bullet is less than 5 kilogram meters per second. I just did a lot of math and wanted to put something on the screen. It's actually beyond my level of physics knowledge, so I emailed askthephysicist.com, which almost got me an answer, but then I mentioned Flat Earth, and the last email he sent was, I have gotten so sick of the Flat Earth idiocy that I no longer waste my time on debunking it, so I don't have an answer to this.
But and for your radiation, they got tinfoil in there. Yeah, they got tinfoil. Protects from the radiation. Anyways, you can't get too much detail on the fabrics that are in there. They'll say, oh, this is a rip knot fabric and all this, but they don't give you the, you know, what is it, what's it made of? How is it woven or anything like that. But anyways, it stops these extreme high velocity pellets of solid rock. Bing! It goes up. There it is. So when they landed on the moon, that sandblast of micrometeors that are going all the time should have sanded those visors right down. They shouldn't have been able to see. Like, where are you, Buzz? I mean, you just wouldn't be able to see. And for the ISS, International Space Station, to be up there that long, they themselves, NASA says, it's thin. The walls are thin. And yet, that should have been sandpapered right through, right through. And there's no sign. Everything looks brand new. The astronauts go up and, look at me, mama. Oh, I have to pee so bad. And, you know, and they're up there and everything is in so pristine condition. The paint hasn't been peeled off or brazed off. What's going on? I don't get it. I'm just a simple man. Sorry, I'm not a troll. You know, I'm not trying to troll you. I'm not trying to convince you of anything. I just don't get it.
My guess would be that the walls are pretty strong because they also hold in the oxygen that the astronauts breathe. Probably mean thin compared to brick walls on Earth, not paper thin. Also, I did some more Googling and I found that the ISS has not had many problems with micrometeorites in the past 15 years that it's been in operation. Even so, a solar panel was hit by one and it caused this hole. From everything I read, it seems like micrometeorites are pretty common, but not common enough to be like a sandblaster. But then again, I'm not sure. The ISS uses Whipple shielding, which essentially has an outer wall, an inner wall, and some space in between. The outer wall is hit and the micrometeorites go through, but they're broken up, so the inner wall doesn't have to withstand as much force.
And I don't get people when they try to explain this silliness. Anyways, it should have been all sandblasted, all where it says, you know, all this USA or whatever, NASA, yeah, the NASA emblem, you know that one. That should have been sanded right off within seconds of going into space. The second these ships go into space, but then they come down. And I'm starting to notice that a couple of these...
Okay, I'm going to stop here. This will be the first two-parter, mostly because I want to do this video right, and I'm quite sleep-deprived at the moment. So follow me on Minds, Twitter, and DeviantArt, though I don't do much there. Links to that and to the original video are in the description. Subscribe, because, well, I have 30 subscribers on Minds and 9 on YouTube. I hope you enjoyed.